Hi guys, welcome back. This is episode 2 and we're going to be talking how to get TFT displays going and the resources that we have in order to do that. And as you can see, I have, let me get rid of the text here. I have my ESP32 S3 USB OTG device over here with a little display on it, and currently it says press a button. And we have a bigger display here on this ESP32C3 stamp, which is running this display. And as you can see, we can also do sort of like graphics and things, and not just text. That's just one way of doing it. Much later on, at a future episode, we'll be looking at the LVGL or whatever it's called, Studio and so on, how to do GUIs on these things. But for now, all we want to know is how to display text, so we can actually use it for displaying, while it is running, what we find saves us having to use the serial monitor. Okay, so in episode 1, we indicated that we're going to be using Visual Studio Code and PlatformIO. If you are already familiar with the system, then feel free to look in the description or to go to the progress bar below, and there should be chapter markers there. You can forward to the next chapter. But I figured that some of you might be new to PlatformIO, and a quick little review of the features there might be helpful, especially since PlatformIO is actually an adjunct to the Visual Studio Code, and the actual options are in various different places, and it might be helpful to show where they are. So if you are coming into Visual Studio Code, and as you can see, show welcome page on startup, if that is checked, you will be greeted with this page. And from here you can actually click on open folder, and if you've got an existing PlatformIO Arduino kind of project in a folder, then that would work for you. It will open up the files and display it on a bar on the side. I, however, already have, it knows about some projects that I've done, so I can just click on, like for instance, the TFT one. We're going to be looking at how to make those TFT LED displays work. So if I click on that, it'll get us straight in there, and you will find that there is several options over here. There is that little PlatformIO icon over there, a little creature, I don't know what it is, but if you click on that, you'll get more features to actually control some of the PlatformIO settings and to clean up and so on. But mostly you'll be using those little icons that started to show up down below here. This is for the PlatformIO home. This is where you do the build. This is very similar that you have in the Arduino IDE, but they have it at the top as buttons, but here it's at the bottom. This is the upload, and here is a function that's called clean, and that's important to know what that does, because we will discuss that in a minute. And here is a test. Now if you are doing commercial software, you usually have a test section there to test to do unit tests, and that would of course go into this folder here, but there's nothing in there, and I don't tend to do those just for hobby use or for just for makers. And the serial monitor, you can click on that little plug over here and get into the serial monitor mode. There of course is a terminal that will pop up. if you have multiple projects loaded, which you can do, you will find that you have a default, but I don't tend to use that feature. Like you can have a workspace with multiple projects in it, and you can go from one to the other, and then you'd have to make sure that the right project you selected when you do a build. But as I said, it'll default to just the one that there is there. This over here will actually show you which COM ports are currently connected. Now I've got this set to COM17, and in fact you see this is a PlatformIO IDE file, which actually sits over here. It usually opens it up by default, and this is where you create the settings for your application over here. We'll get into that in a second. We'll just have a look at some other options over here that it has first. So you will find that this thing over here has a library involved with it, the TFT ESPI library. And if you want to know what those files are, it's pretty easy. In PlatformIO, you have a .pio entry over here, and you can actually go to libdeps over here, and then you'll find out this is where the TFT ESPI, and these are all the files that it pulled in when I installed the library. And we will get back to that in a minute as well. So first of all, if you click on PlatformIO Home, you'll end up with this page here. And this is where you can actually select the actual boards and the libraries. That's usually the two most likely things that you will do. Of course, if you have existing projects like I do, you can select projects here. There is some configuration that you can do over there, which you don't really have to go into very much unless it is something very specific that you have to do. There is an inspect feature over here, which you can actually run, and it tells you how much memory your project is using and some other stuff there. It can be a little bit slow if the project is big, but sometimes if you can't upload it properly to your microcontroller or something, maybe it's using more resources than what it has, and so on. So you can actually use that, I think, to see what's going on. It'll show you some problems in the code as well, potentially. Libraries is over here, and just like you do in the Arduino IDE, which comes up at the side there, but here you will actually search for the libraries. For instance, I installed the TFT ESPI library, and there it is there by Mr. Bodmer. So you would select that like so, and then you can say add to project, and it'll install that into the PlatformIO INI file like you saw, and it'll end up over here in this libdeps library section once it's been installed. If you're creating your own libraries, you actually have a lib folder over here where you can put your own library file, and that then becomes only visible to that project, of course. But there are ways of installing the library into the system here, so you can use it in other projects as well. But that's outside of the purview of what we are looking at right now. So next thing is boards, and you will find that you can look for boards, and if you're using ESP32 boards, then they may or may not be there. So the most likely one that is common to most of them. Like if you buy one of these boards from AliExpress and so on, and it's not commonly used, you might find that you can use this expressive ESP32 dev module. If the board isn't there, you can submit a feature request. You can say, hey, I've got this board, and you give them the information, and if it's enough people asking for it, they will create the board definition here. I believe they've got over 800 boards available, but many of them are Arduino boards and so on like that. So now the board I'm using is actually wasn't there. ESP32 S3. The S3 version has become my most popular board that I like to use because it has an OTG option, so you can actually have a host USB port on it. So if I say look for that, it appears to be there, but that's because I created the actual board file for it and actually installed it. And we will have a look at that in a minute, what I did there. So from here you can actually select the board for your project. Okay, so when we're talking about boards, as I said, I created this ESP32 S3 USB OTG board, and you can see it reflected over here in the PlatformIO file because that's the board I selected. So what did I do in order to get that board in there? Well, I went to the folder where the board files are described, and this is actually in C users, and your username would be there, but in my case it says info because that's my username on this computer. .platformio platforms expressive 32 boards, and expressive 32, that's for the ESP32 boards, are all kept. And there is one of them over here that is the most common, or the expressive S3 board. So I actually used that as a starting point. I copied that to a new file, and I called it ESP32 S3 USB OTG JSON. Now if you go to the PlatformIO website, they have a page on what you're supposed to do, and basically it says, oh, look at some other files or look at the source code. They don't give you any information actually what these things are actually for, as far as I can tell. Like, you've got flags, you've got hardware IDs and stuff like that. It doesn't really tell you what those things exactly mean and how and when you would adjust those. There is a config file involved. So I went in and looked at this file, and I looked at a whole bunch of other ESP32 S3 boards, and I looked at here's one that has a camera, and so on. There is a number of them. So I used whatever knowledge I have about these things, and I decided to copy some of the features that some of the other boards had that I thought that this USB OTG board from Expressive had, and this is what I ended up with. I added some USB CDC on boot equals 1. To be honest, I'm not even sure what that does, but some of the boards had that, so I thought I'd put it in for good measure. It seems to be working, so I've left it there. We do know that the flash is a quad flash, or QIO is correct for that. The frequencies are correct, and it's got 8 megabytes of flash, also reflected in this. There is a file over here, ESP32S3 out.ld, It's existing. I didn't even look at it. I went into the Arduino IDE and it says board information, and it came back with this stuff over here, which I thought maybe that is what the hardware ID is. I don't know. This value over here came from over here. As you can see, that is the over there. I thought, and I saw some of the other boards that have multiple hardware IDs, so I thought, well, I'll add them together. Again, it's working. So I've learned a long time ago in software development and so on, if it works, don't ask questions, just keep it there. So that's what I do. I saw some boards that had Bluetooth connectivity, and I thought, well, this board is quite advanced, so it must have that as well. So I added that for good measure. I don't know exactly, again, what that ramifications of that is, but the Bluetooth is working. So again, as I said, don't ask questions, it works. So that's what I did, and these were pretty much copied from that other file over there. I do not know what maximum size. Hey, if you guys know anything about that, please put it in the comments and I can update the video with that information. But that's what we have. So that's the board file, and that is how it ends up being selectable as a board in PlatformIO. Now, if you've got another kind of ESP32 board, it might already be listed. You probably don't have to do this. And as I said, if it's a standard ESP32 board, the actual dev module version usually works. And if you've got an S3 board, that one I just showed you, that DevKit one, S3, that DevKit one usually works. So you may not have to do this. But this particular board I have has a lot of stuff on there which is specific to this board, and I found that some of the features didn't work properly, and once I've created this file, they worked. So for what it's worth, that's what I felt like I had to do. Alright, so next, libraries. This library over here has a quirk, and that is that if we go to libdepths again, and we go to TFT ESPI, you will find that it has a user setup its file, and what you're supposed to be doing with this is you go in and you uncomment the correct controller, like this is actually the default file and it's actually wrong for our board, so I would have to go like this and I would have to find the correct driver, which any one of these will do. I think I selected the this one over here. Doesn't seem to make any difference, they both work, so I'd have to go like this, and then there's a whole bunch of other stuff that you'd have to change as well. Some of them need inversion on, some of them off. If it is this is if you're using an ESP8266, which we're not, so we can ignore that. This is for Node MCU, which we're also not using, so in fact you would have to go and go like this, and then you can actually go Control K C and it will comment them all out all together. Control K C is for commenting, and we're using a ESP32 dev board. So you would actually take this over here and go Control K U for uncomment, and so on. So you'd have to prepare this file, and then you'd have to edit these numbers over here, which are not correct for our board either. So, but we don't have to bother with that when we're using PlatformIO, because as you saw, we have these values actually encoded in the platform ini file. They override the values in that file. In fact, when this value over here, user setup loaded, when that is there, it is going to completely ignore the user setup file, and you can put all the values in here. And why is that important? Well, because when you do this clean function over here, and there's another that says complete clean. If you go and click on this little icon here, you get more options, and one of them says complete clean or something like that. What it actually ends up doing is it unloads all the libraries and reinstalls them from the directory. And when it does that, it nicely overrides your user setup file that you edited. So you lose all your setups. So either you'd have to go and edit that again, or you'd have to save that file somewhere else and then copy it back into this folder over here, which is a true pain in the neck. If I'd developed this software, I would not have done that. I would have had some sort of JSON file with those values in it that it would read from a user location. But in any case, you see what it says here. If user setup loaded is defined, then don't do any of this code. As you can see, it's slightly dimmed out. So it is never going to read user setup.h. And there's a comment here that says, let PlatformIO users define settings in PlatformIO IDE, which is what we've done. Apparently there's some notes in the tools folder. I don't even know where that tools folder is hanging out, but in any case, this is what we have. So again, another reason for using PlatformIO, because this is a real pain. Otherwise, if you're using the standard Arduino IDE, of course, the standard Arduino IDE too, it's slow and it is just not quite as powerful. So I suggest getting used to this PlatformIO stuff, because it is just better, and the editor is much more powerful than the Visual Studio Code as well, and you can debug, which you cannot do in the Arduino IDE, except just for half a dozen or so real Arduino boards that allow you, that they have enabled for debug. So in any case, enough of that. So that is what we have done with that library. So that's pretty much all there is, other than this little guy over here. If you click on that, you will get some additional options that you can use. You can open stuff, account, inspect. These are the some of those features are on that home page as well. See libraries, boards, so you don't have to go to the home page. Platforms, devices. Devices is actually the COM ports that you have. Like if I plug this board in over here, and I go to devices, you will find that COM17 is here, which is the on that board, that's the micro USB port that you can use for uploading and so on. That's all that does, and you can also select that from over here. Actually, see it is over there. Then you can say, yeah, that's the one I want to use. But we have it in the platform INI file anyway. See this over there. I put it in there as upload port, so it'll find it. In any case, you don't have to do that. You can actually start debugging from there, and so on and so on. So that is there. And then finally you have project tasks, and this is where you find some of those features that are only available here, like full clean and the standard clean, which is the same as that one over here, and some other features over here that you can use. Some of these things I don't even know exactly what they do. You can actually do an over-the-air image upload over Wi-Fi and so on. Some of these features I must investigate in future. They could be useful. But in any case, so that's what is there, and you can play with those and check them out. Now I made some changes to this user setup file, and I am going to say no, don't save, because I don't care about that. As I said, it's not even read. So that is it. Okay, so let's have a look at the code, that test code that I have developed to test the TFT display in the USB OTG board, ESP32S3 USB OTG board from Expressive that we are using here. So I've been experimenting, and what I have done is I have created a header file, tftutils.h, and I created tftutils cpp file. So what we're trying to achieve here is that I want to put these files in a separate folder, which is what I've done, and keep them for future access. Like for instance, if I want to create some sort of device that I will develop, or something that has that needs a display, then I can just call these two files in, and the code will be there automatically, and I don't have to actually copy and paste a lot of code in the main CPP file. Because what you find when using PlatformIO is that instead of an INO file, you have a main CPP file, and in there, the first thing you would always include in all those files is include Arduino.h, because unlike when you're using the Arduino IDE, which already knows that that's the only option that you have, it enables all these features that for Arduino, like pin mode and all that kind of stuff like you see here. That's all coming out of here. So when using PlatformIO, since it is actually more generic, they created a header file and a library for that. So you always include that first. So if you're converting an INO file from a Arduino environment, you can rename it to main CPP if you want to, and you can actually then the first thing you add there is Arduino.h, and usually there's very little that you have to change because it'll probably just work from there. But I don't like putting all the library code and everything in the main file. I would like to have that separate, as I said, so I can just copy those files into the include section as header files, and the source section, that's the implementation or the CPP files. Now I've done just that for testing in this case, and this code is not necessarily complete code. It is just more or less test code, but it shows how to use the TFT display, and that is all that we're interested in, and that's what we're going to be looking at. So as I said, I created this header file here and it uses TFT espi.h, which is the library that we called in. We set a bunch of parameters, which we don't have to get too excited about. As I said, it's just test code. I'll be playing with this deoxygen commenting, which has been rather useful. Like for instance, if you hover or use that erase thing, you get all that information that you've typed in there. That should be A. Erase a section of the display. Typo. We can fix that. Now it'll say the correct thing. Okay. So I created some functions over here that takes parameters and that hides the actual TFT SPI functions. And you can see that if you go to the CPP file where that stuff is actually defined. I came up with a concept of that I can actually have different modes of the display, and put all there, the font number, the text size, where they should start on the screen, X, Y, or pixel offsets, and line padding, and how many characters, and text size, maximum lines. Put it in a two-dimensional array so that for the mode that you've got selected, you can say, okay, give me the X offset, Y offset, give me the font number, text size, maximum characters, and I can read it out of that array. As I said, just messing around, playing with this, but I'll probably keep that sort of thing anyway. So the actual library itself has a TFT set text size. So I created a method that says set text size. Don't have to put TFT dot in front of it, and as I said, just some test information, and show the text modes are displayed on the screen, stuff like that. So nothing too special there, and I got there's buttons on the board, so I have a little method there, a function rather, to read that. And you can read the voltages of the battery and of the USB port on this board. They have pins assigned for that. So for testing, I thought, let's read that, and then we can show the voltage, and you'll see that happening. The loop just looks if there is a button pressed, and if there is, do something; if there isn't, do nothing. And that's basically it. That's the test program. So now let's have a look if it works. Okay, so there's our message. Press a button, and the battery is off. So I'm actually powering it through this. Right now it's being powered through this USB UART thing that I used to upload the code with. I could have uploaded the code with this USB def as well on a different COM port, but not doing that because I want to demonstrate something here. So remember, if I said press menu, it'll actually measure the voltages. Now, right now the battery is off and there is no voltage on this device port. If I plug the device port in and I push the button again, now we see that we have 5.08 volts. Likewise, if I turn the battery on and I push the button again, now we have 4.16 volts from this little lithium battery that is plugged into it. So that's working. If I push this button here, it shows you the actual mode that is in mode 0, font 4, text size 1. And now I can push the up or down buttons. I'll go up, and now it is in mode 1, font 4, text size 2. So it suddenly became a lot bigger. And that's the mode number 2, which is actually font 2, which is a different font. Text size 1 is much smaller. And here is mode 3, which is quite tiny because you can get a lot more text there. So everything is working as we intended it. And turn the battery off. I can unplug that. And so that's it. This is how you can get the TFT display to work. So now let's have a look at the other device that I had with that clock on it. So here we have a 3-point-inch TFT screen that runs fine with that same TFT ESPI library. As you can see, you can do graphics with it as well. And we're actually running it off a different microcontroller here, ESP32C3. And normally you would only need about 5 wires to run it, including the plus 5 volts and ground. but this thing has touch, and it also has underneath it a little card reader which you can stick one of those little SD cards in. So I've got all that wired up for a future episode where we're going to be testing those features as well. But let's have a code just for the display right now. Okay, for this one, the actual PlatformIO people, no one has made a Word file for this M5 stamp-C3. There is an M5 stamp-S3, but this is not what I have. I got some on order, they're coming, but right now I'm running it off the C3, so I have actually used the ESP32C3 dev kit -02. Seems to work just fine, so that is sometimes what you can, as I said before, what you can do. Again, we have our build flags here, but now they are quite different. This larger 3.2-inch display has an ILI 9341 board in it, and I've selected this driver here. There is an RGB order, which is TFT BGR. TFT inversion is on. So remember, before we actually didn't have to specify that for the other board. I'm not specifying width and height here because it doesn't use it with that particular controller. Probably it knows it already or something like that. The backlight is on pin GPIO pin 4. We don't have to specify anything here. Again, we do not have the MISO available on that screen there. It does have touch, so I have not enabled the touch yet. That's yet another thing that we're going to try, but for this we're just for now we're only displaying the pins, mostly clock, CSDC, RST, 6, 5, 10, 7, 8 and so on. The rest is similar. I did add the touch frequency and again disable all library warnings. So that is what we have there. I do not have any includes or header files here because I said it is actually a demo file that I copied and didn't have to change at all. But it shows you how you can draw on the thing. It's so that all the code for TFT is all in the one file here. And fill the screen with TFT gray, set the text color to white with a gray background, draw the clock face, TFT fill circle. So that is how they do that. Draw 12 lines. There's the little tick marks, I guess, for the hours and something. And the dots for the actual minutes. And fills the circle. Draw center string time flies. That's what it shows on the bottom. And then there's a loop, and every second it updates it. A little bit of trigonometry here in order to work out how to display the little arms, the hour, minute, and the second one from the center to the right position. I'm glad I didn't have to work that out because it's my trigonometry day are a long time ago. And so it is. So that shows you the drawing, draw lines, draw circles, it can draw squares, it can do all sorts of things. It also has the ability to create sprites and move those around. That's sometimes the only way to get smooth moving little graphics or images, move them around smoothly. So that is that. This is the actual display we're using over here, and all the information that you need to know of is here. See the ILI 9341 is the IC, and all that information I got from over here. The actual pin numbers, as you can see, that we're using 6, 7, 8, 9, 10, and so on. So that's it. So next, in the next episode, we are going to go and investigate the USB ports on that OTG board. And first we're going to use the USB port for output. We'll plug it into a computer and emulate a keyboard. Then in the next episode we're going to then use the Bluetooth in order to output data in keyboard mode. And then after that we'll do an episode on how to make the USB host port work, so we can actually plug the keyboard into the microcontroller and get it to read the key codes, key presses. And then after that we are going to combine all that information that we have, and the plan is to input key codes, and then we can work on them and make like macros and things like that for keyboards and what have you, and then output it through the Bluetooth. So we actually have a keyboard dongle, if you like, and stuff like that, and then we go on from there. So don't forget to subscribe, and as I said in the other episodes, if you like these videos where we're investigating how to get these things working, then subscribe and like and hit the little bell button, and so you get notified when there's some new episodes in this series. They will be in a view list that will be called ESP32 Adventures. So I'll see you guys later.